We did it. Whew. Still live. Archive was especially juicy today. There was some really interesting stories. I was looking through Archive to just, to feed the machine. And there was some amazing stories. Some that I would have been grabbed before that I just like, I got too much of that. Too much of, like, someone was going into the science of the Penrose process.
Did you put them up on the Universe Today wish list for articles to write?
I did, yeah. I put a bunch of them
look.
are up there. Yeah, there was one about that Venus, that volcanism on Venus, like volcanism has been responsible for most of Earth's mass extinction events, and it's probably the event that pushed Venus into a runaway greenhouse effect, and it's not too weird to think that it could have done the same to the Earth, that we were one bad volcano away from a runaway greenhouse effect.
Although, to be fair, we've had some pretty whoppers for volcanoes in the past. I mean, we think of Yellowstone as huge, but compared to the Siberian traps, it's nothing.
Yeah. So it is interesting to sort of just think that we were that close. There was some stuff about the Earth's upper atmosphere. There's some stuff about I don't know. It just felt like Astro PH was just popping today, and I was
interesting.
But maybe I just understand more now. Maybe that's the problem, is that I look at the list, I'm like, ooh, that's cool. Oh, that's amazing. Now that I can actually understand all the various words that are organized in a various collection. But
see, that's the problem with science education. The more you know, the more there is to know.
I know. The more questions you have, yeah. It's interesting as my education increases, and as I reach out to more researchers and I talk to them, I'm now I like to live right at the edge of my own understanding and try to be that bridge. But it was great. Like, I had a chance to interview someone who focuses on orbital dynamics, and it was just amazing. Like, just every question about orbital dynamics that I could think of, including what's her favorite Lagrange point. Which was fun. Yeah. L4. L5.
I'm going to go with Earth, Moon, L2.
L2, I was going to say James Webb too.
Yeah, so hers was Earth, Moon, Earth, Sun, L4, and L5.
They're probably asteroids.
Those are pretty darn neat.
Yeah.
Well,
I like L7, but it turns out that's a rock band.
Yeah, that's right.
Well, for her, the question was, this is Renu Malhotra. She's with the Lunar and Planetary Science Center. And her question is, why isn't there more stuff in the L4, L5? There should be
some small
a lot,
Earth
but there's
Trojans,
only, from what we know, one object on each Lagrange point, which is weird. And what's that about? And the thinking is that it's collisions inside the Lagrange region, because it's smaller. They're colliding, and they're either turning into dust that's getting spread out into space, or they're just pushing each other out.
The Chinese Chang'e 5, I just came across this in research. The sample return orbiter that did the Earth flyby is being repurposed. It's supposed to be looking at the L4, L5 points, possibly for Earth Trojans. Yeah. So they're using it as a survey mission.
Yep. Very cool.
Nice.
Yeah.
All right. You know what? It feels like it's time to begin. So let's do it. Whoa. Whoever just muted their microphone, that was the right move.
Not me.
Yeah. But background noise just disappeared. So whatever that was. All right. Hello and welcome to the Weekly Space Hangout for Wednesday, April 27th, 2022. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about more updates on the Decadal survey, new type of stellar explosion, 8 missions got extensions, including Osiris-Rex, the oldest account of auroras in Chinese records, and more. Joining me this week, we've got, to my right, Alan Versfeld. Alan.
Hi, it's good to be back.
Yeah, and as always, I have to just thank you from the bottom of my heart for showing up at whatever ludicrous time it is in the morning for you. You're a hero.
It's a great excuse When I'm not well prepared, I can just say that I'm tired.
I'm so tired. I tried, but I'm having trouble focusing. No, you're a hero to us all. We've got Dave Dickinson. Hey, Dave.
Hey, you're catching me at the end of a long day too. I was up for the Crew 4 launch to watch it pass by Norfolk this morning, and now I'm watching it live, arriving at the International Space Station.
They launched?
Yeah, they launched this morning. It was like I got up at 3:30. We saw it come as a little red comet. You could see the second stage going. I knew it was going to go up the East Coast, and I looked out this morning and saw it was clear. So I was like, I'll go up to the rooftop and watch. And we did see. It wasn't the most dramatic launch, but we did see it. So
that's incredible.
Yeah,
the fact that you can see these things.
Yeah.
And we got Dr. Nick Castle. Hey, Nick.
Hey, Fraser. Sorry for the background noise.
Usually it's a microphone trying really hard on the gain, but yeah. So as long as you just mute when you feel like you have nothing to say,
sounds good.
Yeah, that's totally fine. All right. Before we get into our very special guest this week, I want to give a huge shout out and thank you to our good friends of the Weekly Space Hangout crew. They are our fans, executive producers of the show. If you want that kind of power to bring on special guests, to really influence the space agency, to mint doctorates, you should join the WSH crew. Go to wshcrew.space and they will give you all the information you need to join up. All right, let's get into this week's special guest. We got Dr. Paul Sutter. Hey, Paul.
Hey, how's it going, Fraser?
One-time co-host, now
renegade,
globe trotting astrophysicist to the stars. So
mercenary
so
astrophysicist.
Our what is it? Our tamed astrophysicist.
Yes.
There's no specific book to shamelessly self-promote.
I wish there was. That'd be nice.
So, is that a story? Do you want to go into this, or?
Yeah, no, because it's not all complaining. It's actually hopeful. So 2 years ago, my last book, How to Die in Space, came out right in June, right in the peak of the pandemic, right when everybody was in lockdown. It was not the greatest time for a book to come out, and so my entire book tour. And especially with the title of How to Die in Space, that was not, but just publisher schedules, this was set a year in advance. There was no way to change it once that train leaves the station.
Yeah.
And so all my entire book tour got canceled. Finally, now, 2 years later, I am back on tour. So I am going to be in Miami. I'm going to be in San Francisco. I'm going to be in Boston over the next few months of speaking both virtually and in person. It's going to be a lot of fun. But that summer of 2020, I decided as my coronavirus lockdown project, I would write another book. And this book was very, very personal to me. I titled it A Sickness in Science, The Problems with Modern Science and How to Fix Them. And this is based partly on my own experiences through academia, through getting a PhD, having postdocs, research positions, et cetera, things I found a little bit off and a little bit wrong and a little bit strange about not science itself, which I adore and I love and I think is a very powerful and useful tool for understanding the natural world, but how science is done in the modern world. And I started researching. The more I researched, of course, this is a great example of confirmation bias. I went out looking for issues with how science is done. And what do you know? I found a bunch of issues with how science is done. But I found I was not alone, that the thoughts and misgivings that I had throughout my career have been shared by many people.
Well, so you sent me a copy just after you had written it, and I think I was one of the few people to have read it, and it was fantastic. It was absolutely terrific. I was gripped. I read it literally from start to back, over the course of an evening. It was that good. And you, like, there has been this sort of similar perspective that I've been getting as an outside observer. I'm not a scientist, but I connect with scientists. I talk to them all the time. I see how they do their work. I am the result of one of the hoses that comes out of the science machine that is attempting to influence what we publish on Universe Today, that is trying to communicate, and yet at the same time is falling all over itself in weird hypocritical ways and getting in the way of this process. And so I had these observations about how I thought everything, I could start to get this sense that things are coming off the things aren't on the rails as nicely as they should be. And in reading your book, what it's like from the other side was just perfect, because it just solidified in my mind, oh, I understand now why all this is happening. I understand why I get these press releases and not those press releases, why these people are encouraged in these ways and those people aren't encouraged in those ways, and so on and so forth. It was really eye-opening. So where's the book, Paul? Why can't everybody read this amazing book that I'm raving about?
So I wrote this, and I had a publishing contract with an academic publisher who will, out of respect and attempt to be a better person, I will not name. And academic publishers, for those of you who don't know, traditional book publishers, you write a pitch for the book, you write a sample chapter, you outline the book, you talk about your competition, you talk about your own platform, and a publisher decides right then and there whether to run with the book or not. And if they run with it, you write it. Obviously, if you just write nonsense garbage, they can cancel the contract, but as long as it aligns with your initial proposal, they will run it. Academic publishers go a little bit differently. It starts out the same, but then they send out the manuscript, the completed manuscript, to anonymous referees. And wouldn't you know it, one of the topics I talk about in my book is the problem with the peer review system.
Yeah.
We actually, I know a lot of science journalists. I know, Fraser, you are much more keen and aware of this than most people. Peer review is not a gold standard. Peer review is not a guarantee of an accuracy or correctness or even goodness of science.
Okay, so when people, like when we used to report on non-peer reviewed journals, stuff that's in pre-press, stuff that's in archive, and people would say, that's not peer reviewed. And I'd be like, oh, you got me. You're right. I am not respecting the scientific process, But now I know, like, who cares? Like, peer review is not a bunch of people who are coming in very carefully with deep knowledge, double checking every fact and figure, running independent studies, weeding out all the confirmation bias and rerunning the experiment to get repeatability, and then it's able. No, peer review is like a light spell check, and depending on the peer review. And that's what I found really interesting, right? Some of it is the best, and some of it is non-existent. Mind blown.
Some peer reviewers, and I've been a peer reviewer, I have had my own papers peer reviewed. Some peer reviews you encounter are just like, you can tell they didn't even read. They're like, yeah, it's fine, whatever, publish. Right. And then some peer reviewers turn out to be your mortal lifelong enemy, and 20 years ago you insulted their mother, and they will find every single thing wrong with your paper, whether it's justified or not, and they will mire the process down so much that you can't advance your publication with that journal, and you end up just retracting and submitting it somewhere else. And then that's also an issue, because sometimes you do encounter real peer reviewers who do a good job, find critical mistakes in the paper, and then the authors just pull their paper from that journal and submit it somewhere else and get a different peer reviewer that passes the paper. So in general, peer review is meaningless.
Right. Perfect. So you know what? We're publishing pre-press, non-peer reviewed stories on Universe Today all day, every day. Try to stop me.
Yeah, because it turns out it doesn't matter, but except in the case of my book where it did matter, because of the 3 anonymous reviewers. One of them identified themselves as being in a faculty position. This was a scientist, a research professor. And this person hated my book, hated my tone, hated my style. It was actually quite impressive, their review, and the vast majority of it was unsubstantiated, had nothing to do with the content of the book, but just hated me personally. And unfortunately, that bad review led to the publisher pulling out of the process and just canceling the entire contract because they were nervous about what this reviewer had said. And I've dealt with very negative referee reports before in the past. I've dealt with these kinds of personalities before. They're a dime a dozen in science, I suppose also in the world. But I have more experience with the ones in science. And I know how to handle them where you agree, you disagree, you can write, you can rebut the arguments. Sometimes you can find little kernels of valid arguments buried somewhere in their nastiness. And then you pull that out and use that to improve the manuscript. And unfortunately, it just didn't work out.
I was going to say, as a writer, that's the criticism you want to have sometimes. That's hard to get, actually.
Exactly. So like good but strong but fair criticism is always helpful. A strong but unfair and unreasonable criticism is navigable because you can at least find some kernels that you can find useful to improve your manuscript.
Well, this is where the associate editor is supposed to step in and help be the arbiter between the independent review and the author and help work out what's reasonable and what's not. This is where I've run into troubles where I didn't know that was my mortal enemy, but it was because I attacked their thesis and they hated me for it.
Yep.
Right.
And if the associate editor just rolls over, it doesn't go anywhere.
Exactly.
But this is so meta, Paul. Like the issues that you had in getting your book published are indicative of the problem with the with science.
So congratulations, anonymous reviewer number 3. You are now a paragraph in my book on the chapter on how peer review is broken.
So good.
And my
so
agent,
if you need about a dozen more examples, let me know. I'll write you a chapter.
Exactly. And I think this book, scientists, people further along in the career path in the sciences, none of this comes as any surprise. Nothing I write about comes as any surprise. People younger in junior scientists, we're talking undergraduate, graduate students, even postdocs, a lot of it will be a surprise because this kind of stuff is not in the brochure. And then to the general public, this is absolutely mind-blowing. This is not how you expect science to work. Things like how scientists, because grants are so tough to get, we're forced as scientists to just make tiny little improvements on existing knowledge. We're actually discouraged from pushing in interesting new directions that we just might find interesting and curious for ourselves because those are harder to get funding for. Realities like the lack of jobs. We are producing 10 PhDs in the sciences for every 1 to 2 open faculty positions every single year. So we're overproducing. And those people who get PhDs, they have to figure it out on their own because the graduate programs themselves don't offer like job training programs or job fairs or connections to industry. You're just, oh, you didn't get a job in academia? Sorry.
Sorry, you spent $100,000 because people told you it was a good idea to get into STEM. We need to encourage more people to get into STEM.
Here's one of the interesting things. The arbiters of the process are the ones who succeeded. So they don't understand what else can happen. And I love that statistic you brought up of 10 to 1. And think about it this way. The professor that trained those 10 students retired. So there's 9 extra slots to fill. And no one in academia has done anything outside of academia. So where do those 9 go?
Yeah, exactly. And I talk about this a lot. Science is run by scientists. It's scientists who serve on hiring committees and grant committees and tenure review committees and graduate application committees. It's run by scientists. And the solution to these problems has to come from scientists themselves. If we want better engagement with the public, which is something I write about in the book, where scientists should have a more direct and authentic connection with the public, it's up to the scientists to do it. No one else is going to do it.
The scientists are discouraged to do it.
Absolutely. At best, it's neutral. in advancing your career. But if you do a little bit too much, then it's definitely a negative, and you simply don't get tenure.
I've been really fortunate to be spending time over the last, say, 15 years, getting a chance to watch Pamela deal with this through her work with Astronomy Cast and all the various educational groups that she's been with on the side as well. And she is ranting in the chat right now as we're talking. As our engineer, that like I think you're exactly right. I feel like somebody, and my tone with the when I do my QAs, people are like, I want to be an astronomer. I'm like, okay, here's the deal. I think it's been really helpful for me to provide as a communicator to science community, to try to at least speak for those who can't speak, to provide this information, and I think it's just vital. How do we get this book out, Paul?
That's a good question. So my agent has been, all this went down last fall with the existing publisher, cut the deal, cut the cord out of it, had to send my advance back, the whole deal. And my agent has been hard at work pitching it to other publishers. And when you hear stories like Harry Potter was rejected by 48 publishers before, that's true for every single book. Every single book is rejected the vast majority of the time. Both of my books that are currently published and thankfully doing very well were rejected by dozens of publishers before they found a home. So we're in that phase right now where I'm getting a lot of rejections. and I understand it's just part of the process. I have considered self-publishing it, but what I'm worried about with self-publishing is my fans, my audience, the people I'm connected to already know good chunks of this because this has been a part of my science communication and outreach for quite a while. And so yes, they'll buy the book and I'll get some money, and that'd be nice, and I'll get the word out. But I need this book to get in the hands of people that don't follow me, the people I'm not connected to. I need this book to get in the hands of non-scientists and people who aren't fans of science. And so that's why I want to go with the traditional publisher. We'll see if the time isn't right for this book, that's fine. I'm already at peace with that, and I've already started working on a new book to send around. And maybe it's not going to be my next book. Maybe this book is a few down the road. Who knows?
Well, but I mean, who knows? I mean, but by that time, all of the problems you address in science will have been completely solved, and your book will be unnecessary and irrelevant. What is the?
I hope so. I hope so. I hope this book is unnecessary, and then we can open it up like a time capsule into the early 20th century way that science was done.
So, what is the book idea that you're working on now, or is it too early?
This book, it's not quite too early. What I've been doing, like I mentioned, for nonfiction books, is to write a sample chapter, get an outline of the book. And in this book, I am exploring the nature of the nothing. One of my research areas in cosmology are cosmic voids, the vast expanses of emptiness that dominate the universe. And initially, my book was just going to be about the discovery of cosmic voids and how we've used them and how they've been ignored for decades. And now they're the most powerful probe of structure formation that we have available to us. And that's a really cool story. But then over the past few months, I've been developing this passion for looking at certain problems or certain questions from multiple points of view, and especially points of view outside of physics, and points of view that we don't normally associate with investigating these massive problems. Like if we take the concept of the nothing and the emptiness or the void, this has been explored in music and dance and art and architecture and philosophy, Western philosophy and Eastern philosophy. There's millennia of different threads of thought exploring this concept of what does nothing really mean? Is it an entity in its own right? Is it only a counterbalance to the something? Is it some creative power that allows the somethings to come forth and to exist? And lots of different people from lots of different traditions have explored these this nature. And so I'm going crazy and I'm loving it. And I'm writing a book about all the ways we have probed this unanswerable question, which is, what is the nothing?
So is that the answer? Nothing? Is that the name of the book? Nothing?
No, the name of the book is Truth, Beauty, Darkness.
No, it should be Nothing. Book should be called Nothing.
No,
I'm telling
it's
you.
I like my title. I really
or what
like
is
it.
Nothing? Sure, have that as your subtitle, but I'm have that as your second line. But I'm saying, man, Nothing. Yeah.
And I got the inspiration for this line of thinking from a lot of my science communication work. And one of my most favorite things to do is science and art collaborations. And one thing I'm involved in, for example, is with a modern dance company here in New York City called Siren Modern Dance. And starting years ago, we initiated a collaboration exploring the nature of time. And now we have a stage performance where I get on stage and I talk about the physics of time, or what we know of time through the language of physics, which turns out isn't all that much. And then the dancers and the choreography and the music are also exploring this nature of time, this concept of time that we're all familiar with, and yet somehow we can't exactly put into words, and we can't define, we can't pin down. And I started asking myself, when I'm on stage with these dancers and I'm saying something about relativity or entropy or time dilation, are these things really so far apart from the way that the dancers and the choreographers are understanding time? Is it really so far apart from the way that a psychologist understands time or a neurologist understands time? We're all poking at this same problem from different directions. And there's a lot of interesting answers that we've come up with in this exploration.
Well, it sounds fascinating. And, we didn't even get a chance to even talk about what you're doing with Ars Technica, the series there, which has been absolutely incredible. Would you say that running out today and buying your past books is probably one of the strongest ways to help ensure that your future book deals come together?
What a fantastic segue. Yes, buying my existing books, Your Place in the Universe and How to Die in Space, is great, because then that helps my agent sell the next book.
Perfect. All right. Well, Paul, always a pleasure to talk with you, and keep us posted. Let us know when you do sell the book and everyone can get a chance to read it. As I said,
absolutely.
My pre-review is that it was excellent.
I appreciate that.
All right. Thanks, Paul. Take care. All right, let's move on to the news portion of this week's episode. Nick, you had some stuff you wanted to talk about. Let's talk about the 8 missions. I got some extensions.
Okay. Yeah. So every so often, NASA does something called a senior review, which is where they do a very intensive look at what are the active missions that are applying for an extended mission. That is, the device is still technically feasible. It is still operating. Do we fund it for the next period of years? Usually 2 to 3, maybe even 4 or 5 years. This isn't the normal grant proposal process. A typical grant proposal is asking for something like $250,000 is a big grant proposal per year over the course of it. These are asking for more than that. And so instead of 15 pages, they're actually required 2 40-page segments, as well as a 2-hour session face-to-face with the review panel, which we never get, to talk about, what else is in there, what else should they be highlighted, and what questions does the panel have for the mission team. So this is literally a few of the people higher up in the mission asking the whole rest of us, why should we keep going with funding? So they can prepare a presentation to argue in front of a group of people for money to keep us all going.
Right.
Of these 8 missions that were reviewed, all 8 were suggested to move forward, although some of them with caveats and addendums about, here's how we want to see you change a little bit about your management structure and decision-making process, or, should we tweak the orbit of this orbiter or not? those sorts of things. In fact, one of the missions, it was recommended that they closed down one of the instruments that had lost some of its capabilities. They didn't find that the science it could do was actually worth the cost of keeping the whole instrument support team going. This is the CRISM instrument, if you're curious. And one of the reasons why I really wanted to talk about this is definitely not because it personally affects me as a member of MSL.
Right. I can just imagine that meeting,
missions
though.
on Mars.
Well, I can just imagine they're like, so, you know what? We've decided to shut down Curiosity. That's enough. That's like the rover's in perfect condition. It's still producing a ton of science, but it's just not, we're not into it anymore, man. No.
This is actually one of the things. The rover's not in perfect condition. It's doing great. All the instruments are still healthy. We've got a lot of consumables that are still left to consume.
Its feet are a little sore.
Its feet are a little sore, to put it succinctly. We've got 6 wheels, all of which are in various states of brokenness. They all turn. They're all still functional. But that's only because we've been really careful and really good about what terrain we go over. And if we start rushing that and going over nasty things, like you may remember about a month ago, we talked about gatorback terrain. We looked at that one as a showstopper and said, that's a lot of hard-pointed rocks. We will terminate the mission if we drive over that. So what do? How do we go around? NASA agrees this is a problem, and they're worried about when we're going to run out of wheel wear. When is it just not practical to move the rover anymore? And so they're concerned about what objectives we'll get to as the mission progresses, and wanting to get to a lot of those, because we're in a key location in Mars's history that we may not see much evidence for with Perseverance over in Jezero Crater. And this is the transition from an early wet Mars to an arid environment on Mars, and everything that happened in between, where water went from relatively fresh to very briny, ultimately depositing a ton of sulfates and then disappearing. We're in the prime location to be studying that right now, and for the next course of this extended mission proposal, which was funded, spoilers.
Yeah. But one of the missions got a pretty exciting extension.
Yes. All 8 missions got a good extension. Did we get everything we asked for? Heck no. But then again, that's kind of how science works.
So nobody's sending the wheel repair probe to Mars like you asked.
Oh, that would be really fun.
Yeah.
I'm just picturing the rover design to actually take off the wheels, put new ones on.
Yeah.
Do we have to stand there with our AAA card saying, hi, service, please?
Yeah, it'd be like a race car. No, it'd be like, some special probe would come in and lift it up and just pull off the wheels, put new ones on. Yeah, I believe that's how it would work. Yeah, 6 wheels. I can just imagine a little lander with 6 wheels on board, just enters the atmosphere, lands beside Curiosity, helps swap out the wheels. You're good to go. But yeah, one of those missions got a very exciting extension. I'm not saying that MSL, that Curiosity's extension isn't exciting. It is, Nick. We're all stoked for you. But let's talk about the one that's going somewhere new.
Do you want me to jump in?
Well, that sounds like a segue to Dave.
Yeah.
Oh, sure, Dave. Let's talk about it.
Yeah, one of the big ones is Osiris-Rex, which is coming back and returning its sample from Bennu, asteroid Bennu, next year, September 23rd, 2023, which we're just a little over a year out from. After that, it's going to be transitioning. The team is going to actually split. The University of Arizona team is going to split into the sample recovery team for Osiris-Rex. And then the new team is going to be Osiris-Apex, which is going to be Osiris-Apophis Explorer, which is going to the asteroid Apophis, which was discovered it's about the size of Bennu, but it's a different type of, it's probably a more dense stony asteroid. And it's going to pass the Earth. It caused some controversy and a lot of excitement back when they discovered Apophis in 2004, when they found there was going to be a very close Earth pass on Friday the 13th, 2029. So at first, there was a small possibility that it might actually impact the Earth. Of course, as with most asteroids, more observations, you get a better orbit, a better arc picture of its orbit. They found that it's going to still pass pretty close within the distance of geostationary satellites. And it's actually going to be a 3rd magnitude, 2nd magnitude star for Europe and Africa, I believe, are going to be the best places to see it on April 13th. And it's weird to think 2029 is not that far away now. In 2004, it seemed like it was so far away. It's only 7 years away. It was actually mentioned that we should send a mission to Apophis in the Decadal survey that came out last week. Apophis was mentioned by name. So it'll be interesting to get a close-up look at this. And I talked to one of the researchers, and she was saying that for Osiris Apex, and they said that the encounter is going to be just a few weeks prior to its close pass in April 2029. They should start getting good science images, and they're going to follow it for about 18 months. Osiris-Rex is actually designed for this kind of close rendezvous. It won't be able to return samples because it's already done its whole tag sample thing with Bennu and returned. But we should be able to get up really close and do some spectral analyses and map out Apophis and get really a good sense of what it's going to look like. So that's going to be a very hectic, exciting few weeks in 7 years from now. It's April now, so it's going to be in almost exactly 7 years from now. So
did anyone plan this? Do you think anyone, when they were working out the flight dynamics, thought we could maybe do another flyby and it could be Apophis?
I think they had to look at the delta V. If I remember talking to the researchers, they looked at the delta V of various objects and to see what was approachable. There has to be something in near Earth orbit that they're gonna actually be able to reach. They mentioned too they may still have enough fuel for a third approach to an asteroid. After I asked them that, it's like, is there a possibility we would see something after Apophis? And you see this kind of, we're talking about repurposing missions. It only makes sense if they're out there. They usually have a little bit of extra fuel left on board. JAXA's, Japanese Space Agency's Hayabusa 2 is going after a couple asteroid targets. It's already returned its sample return mission. Was it last year, 2020?
Yeah.
That it returned its sample return. They're going after a few smaller targets of opportunity that are near Earth asteroids in the 2029, 2031 timeframe. And we were talking about just before we went on the Chang'e 5 lunar sample return. The orbiter is still out there. It is going to the Lagrange points to possibly search for Earth Trojan asteroids. So the Chinese are repurposing it.
If they had like a second sample capsule on board that they could have just, right? Because I mean, all the equipment is the same, and it could kiss.
I believe the tag SAM that had the nitrogen gas, it had a few charges left in it too. I think they got their
but they just don't have they just don't have the capsule, the return capsule anymore.
That's going to be jettisoned. And
the unfortunate part is the capsule is a fair amount of mass, and the system you would need to put a new capsule in place is even more mass. So it's really hard to do that kind of thing without the ability to actively service a satellite that's going to go by pretty quick.
Could our wheel repair robot also carry a replacement sample return capsule?
Yeah, that's going to be a lot of different missions going a lot of different directions. I think Delta V would be a problem there.
I guess so. All right. Alan, let's talk about micro-novas.
They are very cute, aren't they? Lovely little things.
In an apocalyptic way.
In a galactic astronomical sense, they're cute because the name comes from it being 1/1,000th, approximately the size of a regular nova explosion, which is still pretty big. I think I wouldn't want to see it up close. Let me start clean there. I had a whole little narrative built up, but forget that. So basically, if you've done any kind of, well, I mean, everybody in the room has, but any kind of introductory astronomy course, or you pick up a popular astronomy book, at some point you're going to come along to the concept of a white dwarf with a orbiting very nearby to another star and close enough. It's within the Roche limit. It's able to draw material, unburnt hydrogen from the surface of the donor star. And this leads to various kinds of fireworks in the sky. So you end up with all this fuel piling up on the white dwarf, and eventually is deep enough that the pressure at the bottom is enough to start fusion again. So this dead star comes back to life, and we have a nova. And occasionally there's enough of it that the mass of that white dwarf built up to the point where it is able to collapse, and you end up with a type 1a supernova. So now we're going the other way around. It turns out that occasionally, if the conditions are just right, instead of having all that material spread out and form a atmosphere or ocean or whatever you would like to say of unburnt hydrogen on the surface of a white dwarf, it can concentrate in areas. It's the magnetic field of the white dwarf. If it's a powerful enough magnetic field, and if the spin is slow enough, you get this concentration of material at the poles. So you get a localized heap of material, for lack of a better word, and it's deep enough, the pressure's enough, it's able to ignite, and fusion can begin, and you end up with this explosion about 1/millionth of the power of a nova explosion because it's localized. It lasts for a couple of hours, and then it's over. Cycle starts all over again, and I just think that's quite fascinating. And just imagining this name micronova, it sounds like such a tiny little thing, but you're still burning through maybe it was about 20,000 trillion tons of material, which again, on a cosmic scale, so what? But can you imagine that much material just going up in a couple of hours?
Fed from a star, from a companion star, channeled by powerful magnetic fields into these blobs, deposited like, I'm imagining like a, I don't know, like a funnel, like something that's just kind of depositing, the magnetic field lines are depositing this material down onto the surface of the white dwarf. And then it just piles up like this little mountain on top of the white dwarf. Now, you said like from the poles. So would you get them happening from like one from a North Pole and then one from a South Pole?
That wasn't covered in the paper. I would imagine so, but I don't know. Maybe you can speak to the author of the paper when they.
Now, what are like? Why aren't all white dwarfs feeding like this, producing these micronovae? Is it special about the companion star? Or is it special about the white dwarf itself?
There's a couple of factors. First up, it's I think primarily it's the spin, the rate at which the white dwarf itself is spinning, which is what tends to distribute the infalling material, and it's the strength of the magnetic field itself. So if the spin is slow enough, and if the magnetic field is powerful enough to be able to concentrate that infalling material and to hold it into a clump, so that it doesn't spread out, then you get this event happening.
I wonder if it's similar to like when a neutron star is first formed, it's usually rapidly spinning, and that's where you get a pulsar. And then slowly, as the neutron star slows down, then the pulsar portion, the magnetic field dies down, and you don't get the pulsars in the same way. You just end up with a regular old neutron star. And I wonder if it's a similar situation, that a freshly born white dwarf, if such a thing is a thing, is when this happens. And then as the system matures, as the white dwarf gains more mass, as it moves farther away from its companion star, whatever, it settles down into a more regular neutron star. I mean, do we need a name for a white dwarf with a powerful magnetic field?
Oh, I think we should. We don't have enough cool names in astronomy.
Yeah, that's producing micronovae, right?
Yeah. Well, that's interesting you mentioned the neutron stars, because there is a similar process happening that's been observed on neutron stars, except instead of shining invisible light, you get X-rays bursting out. And I gathered from the paper that this was understanding this process is what led to solving the mystery of where were these flashes coming from.
Oh, interesting. That's neat. It's interesting to see sort of the same phenomena happen across, and I'm sure you get a version with black holes, but it's coming from the accretion disk around them. But similar sort of situation. Extreme objects, powerful magnetic fields, feeding from companion objects, shenanigans.
Boom.
Boom. Yeah. Very cool. Very interesting. Thank you, Alan.
So this may be a silly question, but are these micronovae enough to actually change the orbital trajectory of the little white dwarf? Or are we still talking scales too small to shift something that massive?
I've never heard, even with regular old novae, which are a million times more powerful, So,
although the regular nova is a symmetrical, it's not
because it feeds across the entire, so it blasts across the entire waistline of the white dwarf. That's interesting.
Yeah, that's why I was thinking about that. I was just curious.
Yeah,
Pamela says no, but
yeah, I mean, I
Pamela
wouldn't think
says no.
It's still more than a solar mass that you're trying to shift.
Yeah.
But I don't know.
Our resident astronomer says no. So we'll go with her expertise. But still, it's very cool, and it definitely captured people's imagination. Nailed it with the press release. It came from the European Southern Observatory, and they absolutely nailed the approach they were going with this. Cute, adorable. It's merely a million times the power of a regular nova, which is dramatically less powerful than a supernova. Aww, so kawaii. All right, Dave, let's talk about auroras seen in historical records.
Yeah, this was an interesting study that came out of Nagoya University that kind of caught my eye a few weeks ago. They were looking at a chronicle called the Bamboo Annals that goes back through Chinese history. It covers a lot of different things, but occasionally it's interspersed with some astronomical observations as well, which are kind of intriguing. This is from 3rd century BC, and it goes back about to 1000 BC, about 2 millennia ago. And Chinese records are actually one of the best records of older astronomical observations. There are records, speaking of supernovae, there's records of the Chinese astronomers saw the Crab Nova, the Crab Nebula supernova. They recorded that. They saw sunspots. They saw naked eye sunspots through fog banks and clouds, that filtered in enough on the horizon where they were actually able to see those. And they made reports of aurora whenever they saw these. In this particular report, they were looking at where they mentioned a 5-colored light that had appeared to the north. And they mentioned it appeared in a particular reign of a particular emperor, particular dynasty. And this kind of became key to locating the actual time. Going back, they were actually able to go back chronologically to within about a decade in the 10th century, which would have been one of the oldest observations we've had of a record of aurora. It was interesting. They noted that this corresponded to I had never heard of this till I read the paper, that there was a time called the Homeric minimum, looking at tree ring data where they can look back through the solar cycles. And they found that this was right before what they called the Homeric minimum, around 8th or 7th century BC, that there was a dip in the solar cycle back then. So right before that, the sun was especially active. And it's kind of interesting because we're going toward an active cycle right now. If you were looking at the sun over the past week, we have a crazy number of sunspots right now. This
is it. This is our time. This is our aurora time.
Yeah.
Also possibly the end of everything, but don't worry about that.
Yeah, there's some talk out there that the solar cycle 25 might actually be stronger than we've had for over a century, and it seems to be overproducing right on schedule. It's going to peak right around 2024, 2025. But just this past week, the sun has been very interesting to watch. There's been some very interesting sunspots. But it's interesting, this record stretches back now over 2 millennia that we actually have. And they talked in the study that the magnetic pole was actually dipped a little more toward, we know from records from other sources, like saying tree ring data, orientation in the rocks and things like that, where the magnetic pole kind of wanders versus the rotational pole. It was dipped more toward northeastern Asia and China at that time. So they probably were seeing more aurora. The aurora oval was probably dipping down over Manchuria and northern China at that point in time. So it's very intriguing that we have that. We broke that record for the oldest observation. So,
and they were able to match it with a solar cycle, and they were able to match it with one of the emperors in the Zhou dynasty. Yeah.
They cited that was really key to getting it into about 1 decade span, which is pretty good going back 2,000 years.
So. And that would sync up, and so this would have been an aurora event, probably seen around the whole world. It was so powerful. No matter where you were, you would have seen it. Absolutely.
It might have been like the Carrington event was one of the biggest ones in modern times, 1859. They saw aurora down in places they never see it, like in the Caribbean. It's like that was.
Can you imagine? Like being in a place like in southern China or being in the Caribbean or, you know, some place that never sees any kind of auroral activity, and suddenly the entire sky is filled with blue and purple and red, the 5 colors that they mentioned, just,
well, even when I was
right out.
When I was a kid, I mean, back in the 70s, I heard some ideas of what auroras were that were wrong, because we'd see them in northern Maine too, and people would say things like it's the reflection of the sun off the polar caps or something like that. So even then, not that far back, people had some erroneous ideas as far as what the aurora were, even in modern times. So
one thing that's really interesting, and this is a total rabbit hole, but Chinese, because it uses the pictures, the pictograms for the characters, you have to remember tens of thousands of characters to because literally, most characters are words and vice versa, and so it's about 3,500, 4,000 characters. Most Chinese people can write 5,000 characters plus, but they are very slow to change, and so I was looking at that document that is from the 4th century BCE, and I could read chunks of it.
Yeah.
Even though it is 2,200 years, 2,400 years old. I saw where it said that they were talking about the 5 colored lights.
5 colored lights. Interesting.
Yeah. And it's kind of fascinating how helpful a language that is very slow to change in, once they go with this written form, they remain largely unchanged for thousands of years. And that's the advantage. And so from a historical perspective, it's kind of fascinating to think that that's probably some of the most useful stuff for historians to look through, because the meaning won't change over tremendous periods of time. While with more, when you only have 26 letters, going from Greek or whatever to modern English is.
You think with English, you go back even to Chaucer, which isn't even a millennia ago, and you realize they spoke radically different.
Yeah. The ancient Chinese, thousands of years ago, wrote their original Chinese letters with a sort of a slightly different version of the script. And same thing, once you learn how, what this character is and what its modern interpretation is, you can read a text written 4,000 years ago as if you were reading it from a modern writer today. It's a mind-bending thing to think about. And so the fact that astronomers are able to rely on this is just absolutely incredible. And I love it.
And meteor showers. They recorded meteor showers.
Yeah.
Some of the earliest records.
Yeah. And they were meticulous record keepers, and the records are maintained to today. And my guess is that there's a lot more information in these ancient records that would be of tremendous value for modern researchers, just like this. Nick, you wanted to mention a few more additional notes on the Decadal survey. You've got about 3 minutes.
So I'll keep it real quick.
Just keep it real.
Things. I mean, this Decadal survey is almost 800 pages long. So it is. That's actually the last Decadal survey, Visions and Voyages. Anyway, the new one, which came out about 8 days ago, is huge. I have not had time to read it yet, but a few things that struck me. One was I was surprised that there wasn't very much talk about what the next mission to Mercury will really look like. There was some, but right now there's a huge controversy over what the heck is the surface made out of, and what does that tell us about the internal processes of Mercury? And really the good way to resolve that is to land something on Mercury. So I'd actually kind of expected and really hoped to see talk about that, and it's just not there.
There were some really interesting proposals for Mercury landers that have been making the rounds. They've come out at some of the conferences. People have done presentations. This is the time for a Mercury lander.
Similarly, I was surprised that there wasn't as much talk about Neptune and its moon Triton as I would have expected. There is a mission concept study that's gotten pretty far along towards sending a mission there, and it's exciting. Neptune's very different from Saturn or Jupiter, and for that matter, from Uranus. And Triton has indications of some very unusual geology. So I would have thought those would rank a little bit higher in the listing. Yeah. But a couple of things that I thought were a little different and really cool to see is the Decadal survey actually talked meta about what's going on in the science community and actually tried to lay out a definition of what exactly astrobiology is and what's its role within planetary science. That's basically awesome. Distinguishing not all planetary science is astrobiology. Astrobiology is important, but it's not the only thing that's important. That said, it sets a lot of the tone for what we're trying to do for the next decade, much as it actually did for the last decade as well. They also took a little while to talk about research and analysis, which is, well, basically what funds all of us scientists. That's what they call the general work we do when we're not literally building a mission or operating it on a computer screen. And talking about what's a reasonable level of funding for that, where's NASA sitting right now, what should count towards that, what shouldn't count towards that. This is huge. Yeah. I mean, this has the potential to revise how all of us work in academia. Yeah. Anyway, there's my short spiel.
Yeah, no, that's good. You kept it under 3 minutes, and it was great to have that perspective. It's funny, like astrobiology has gone from we don't talk about astrobiology to astrobiology is kind of interesting, but just make sure you're mostly doing geology. To okay, fine, we'll teach you astrobiology. To now, astrobiology is one of the main spears forward for us to try and understand our place in the universe, and it's exciting to see this moving forward in this way. Next, maybe SETI gets absorbed and recognized in the astrophysics decadal survey, but maybe that's a bridge too far. I don't know.
Well, to be fair, SETI could be argued to be astrobiology. I mean, if we detect another civilization out there, that's absolutely some fascinating biology.
Yeah, absolutely. All right, well, we've reached the end of our episode. I want to give my co-host a chance to shamelessly self-promote what it is they're working on. Dave Dickinson, what are you working on?
Frequent contributor, Universe Today, Sky and Telescope, Astro Guys with a Z on Twitter. First book with Universe Today.
Woo!
Second book.
We had no problem finding a publisher.
Also came out during the pandemic. Yeah, so I was going to tell. It's like, you want the publisher to chase after you as a writer. Yeah. That's a good thing when they say, when are you going to write another book? So
yeah, but again, I can totally understand. They don't, people don't want to get in trouble with the scientific community. Big science. Awesome. Astro Guys with a Z. That's translating it for the non-American speakers out there. Alan, also fellow Z sayer. What are you working on? And where can people find out more?
Urban-astronomer. Yeah, urban-astronomer.com, where I write the occasional astronomy news article, and where you can find the Urban Astronomer podcast when the next episode comes out. Or on Twitter, very little astronomy there, despite the name, @UAstronomer. And that's what I have to offer.
Fantastic. Nick.
I'm working on stuff for Voices for Science with the American Geophysical Union, and starting to get my social media presence actually, running for a change.
And I look at the Universe Today story assignment tool. I see a story up in there somewhere.
Yep. It turns out Mars-Crete was a really, really deep rabbit hole, and it's been fun to explore, but that's not conducive to writing.
Oh, you're gonna have to learn some time management skills, dude. We'll get you there.
I know.
We'll get you there. Yeah. You're having too much fun. You missed the one of the other writers grabbed the one on how to make concrete out of urine and bacteria.
I saw that.
Yeah, that would have been exciting.
Yeah,
loved it.
That was one of the things I stumbled across while researching Mars-Crete. By the way, this subject is actually so fascinating that I captivated the entire Voices for Science crew by telling the story of how do we make concrete.
So how do we turn your deep rabbit hole fixation into the article that you had originally expressed an interest in writing for Universe Today? That's the final frontier. We'll crack that at some point. But I'm glad I was able to send you into a rabbit hole. That's almost worth it to me, though. I think. to just tie up your brain and send you on these tangents and rabbit holes. Worth it.
I do pick articles that it's like just to learn about what's actually.
Oh yeah, totally. Yeah,
kind of interesting.
It's so much fun. It's the best part about being a journalist.
Yeah, absolutely. All right. So for me, of course, Universe Today and all the things. I've had some just cracking interviews on my channel, so you should definitely listen to them. As I mentioned earlier this week, I talked to Dr. Rehnberg Malhotra, and she was willing to answer every single question I had about orbital dynamics, including what is the best Lagrange point. She gave what has to be a factually correct answer about that. I've got an interesting interview. You're gonna like this, Dave. 8 a.m. on Friday. I'm talking to Frank Marchis from Unistar.
Oh yeah, I've interviewed him before actually. Yeah, he's very interesting.
So I love this idea of automated telescopes, and we'll get to the bottom of it, and hopefully we'll get a much better sense of where this idea came from and what the future holds for this kind of consumer version of robotic telescopes. I'm pretty excited about it.
What's cool with Unistellar is the I mean, I'll just say I like the Vionis ones too, but they're doing actual science with the Unistellar ones, which still blows my mind.
Yeah, absolutely. Just connecting you into this scientific community, a chance to do actual scientific work at the same time that you're taking pretty pictures of space. It's a pretty bold idea.
The fact that they're detecting backyard exoplanets is pretty a few decades ago you couldn't even they weren't even finding exoplanets with major telescopes. So
that's in 2 days. I'll get to the bottom of this and let you know how it turns out. All right. Let's wrap things up. So thank you, everyone, for watching us today here on the Weekly Space Hangout. Thanks, everyone, on YouTube and on Twitch. We really appreciate it. Thanks to all the moderators. Thanks to Nancy for organizing everything behind the scenes. Thanks to our special guest, Paul. Go buy his books. Show that he's a force of astronomical reporting nature. Thanks to all my co-hosts, Alan, Dave, Nick. Awesome to have you guys here. Thanks to our editor, our engineer behind the scenes, Dr. Pamela Gay. She is she's in our hearts this whole time. And we will see all of you next week. Thanks, everyone.